started, please. So today we are going to talk about arrays some more, and I'm going to talk about the next assignment that's coming out this afternoon. And I think it's going to be a cool assignment, so I hope you look forward to it. Okay, so first of all, heads settle down, please, everyone. All right. If you send me an email asking me to regrade or something, I'm sorry, I haven't gotten to it yet. It's on my list. I have a big long list of emails. I've just been working on other stuff for the most part. So I'll try to get to it soon. Assignment 5 released this afternoon, so look for that. And I'll talk about it in class today. Okay, so first I want to make a little clarification on array initialization. If you make an array, and don't give it initial values yourself. So maybe you have an int a equals new int 3. By default, we talked about that's set up with all zeros. So you might see something like that if you print it out. And that's true for primitive arrays. So if you have doubles, it sets it to 0.0. If you make it an array of booleans, booleans are either true or false, and by default, or sort of standard convention, false is often 0, so it makes it an array of falses. But if you have an array of objects, it fills it with null, not some sort of default 0 thing. So if I have string array s equals new string of size 3, that's going to make something that's null, 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 which is not very exciting. The problem with this is if you try to use one of these things, we haven't really talked about length yet, but we will. It tells you how long it is. You can't ask for the length of a null object, and it'll cause an error. So it's not that there's something small in there. Null means like nothing is there, and you can't apply any normal methods and things to it like you would a string. Okay, so you actually have to be careful with these arrays of strings. You need to put a value in it. So how would I put a value in here? What kind of a thing would I need to do to actually make a string for that? Someone give me an idea here. You're just scratching your head. Okay. No. So if I wanted to put some sort of David or something in here, what can I do? Yeah. Well, I need to actually somehow assign that to this location, though, right? So if S is my array, what is that location there?
It's location index 0.
Yeah, so at S0, what can I do? Assign a string in there. I can make a new string as well. Actually, not when I say that. So what I was saying here, the other choice is to say, okay, I need a string for here. Let's make a string. And that's the same kind of deal. Give a value. Once that happens, then the string is hanging out in that 0 index location. Okay? So anyway, this will catch you a lot of times because you're used to this filling it with sort of friendly yet default values. A bunch of nulls are not friendly at all. They will crash your program pretty quickly unless you check for them.
Do we need to create a valid variable for all of them? Or as long as we have one full, now we can use our length command and figure out?
No, I mean, so let's say we put something in S0. If I try to do something in S1 without having assigned anything in there, that's still null, right? It's still saying, what is the length of null, basically?
I thought the length command was...
No, the length, S dot length is 3. That's the length of the S array. The length of the string in a particular location, once it looks at this, it turns that into some sort of string here. Yeah. Right? So there's levels here, layers. These layers are what trip people up a lot, right? You have to drill down and think about, is this the S array, or is this the string held in the S array, or is this an array held inside the S array kind of thing, or something else? So you can get complicated very quickly with this kind of thing. Okay. Now let's think about arrays a little bit more. I mean, we've used a string in these last assignments with scanners to hold all sorts of information, and that's very convenient in a way. We can put in names and numbers. We can actually mix different types. So that seems cool. Whereas arrays, we're limited to it only being one type, an array of ints or array of strings. So why would I use an array instead of just like using strings? What do you think an advantage of an array might be?
You don't have to like convert it into your.
Yeah, so for me to pull out this number here, it's actually going through a process of pulling that out as a string, 12. And then to make that into an actual number 12, that's a fairly complicated process, right? It's not just some automatic thing. It takes some time to make that conversion. So the fact that you have to kind of slowly convert everything from a string into the value you want to use it as is a downside of using strings and scanners. What's another downside of using strings and scanners?
You can't like change something in a string unless you write it over again.
Yeah, so the scanner, once you set it up, is kind of fixed, so you can't use it to like accumulate answers of some kind. That's a good answer. Anything else you can think of?
Arrays, you can access each element when you need it instead of having to go through.
Okay, yeah, so in a scanner, we say, give me the next token, 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 and you're forced to read them off one at a time. With an array, I can access any one of these in any order I want. I could look at this one, and then this one, and this one. I could just look at that one if I wanted to. So I have that index number that lets me freely index into the array however often I want. So arrays do have advantages. They're more efficient for the type of data they have, and the access is a little more general. So I know you're getting sort of comfortable with scanners, but in general, that's sort of us hacking scanners to make sort of hold collections of data, and they're not really designed for that. They're really just really more like use some text and you want to process it in that specific case. So arrays are a little more general and used a little more often. Okay, so questions on that? Kind of get the, there's pluses and minuses on each data structure. Scanner holds general things, but it's slow and the access is very fixed. So arrays are more efficient and general access, but they're restricted to one kind of data per array, right? So just keep that in mind. There's reasons to have two different styles of things here. All right, so when we were using scanners and strings, we looked at these different kinds of looping patterns. And let's just look at these in the context of arrays, because this is sort of the more natural fit in some sense. First of all, loops and arrays work together very well. So let me make, what do I want to do here? Net array, and I'm going to make this void. All right, let's make a little method that fills an array with numbers, basically 0, 1, 2, 3, 4, 5 kind of thing. So instead of defaulting to 0, we want to just have a nice little sequence of numbers in our array. So we're going to pass an array into this method. And I give the type of the parameter, it's an int array, and I give it a parameter name, array. So up here we might call init array with and pass in an array as an argument, and that reference gets copied here to array. So given an array of some size, I want to come out 1, 0, 1, 2, 3, 4, 5, however long it is. So I need to loop over each element of the array and fill it up somehow. Let's kind of start things off up here. So I'm going to make an int array of values, and I'm going to make that a new int array of size 5. And if I print it out, which is the array, I got a toString of values, and I got to wrap all that in a system out. Oops. All right, so we want to see what's in here, and I have to import the arrays class for this to work. Okay, so I'm saying take values, convert to a string, which is this kind of form here, and print it out so you can see, hopefully that's filled with all zeros. And then I want to pass this to init array. And when it comes out, it should be filled with 0, 1, 2, 3, 4 kind of values. Okay? That's the goal here. So we want to modify this array inside here. So what do I need to do this? How am I going to change all these values? I'm going to call the change array values method, and I'm done, right? No. I need to write this code. So what's the basic idea how I'm doing this? I'm doing this kind of thing not to get an answer from you, but to hint what kind of thing I want. A loop. Yes, I want a loop. So let's make a loop, and we're going to loop over the index locations of the array. And I do like to use index as my little counting variable in a loop because that's really what it is here. I'm starting at index 0, so I'm going to initialize it to 0, and I'm going to go until the end of the array. And array has something called a property that's its length. So an array knows how long it is. All right, that's a very handy thing. Otherwise, we'd be just guessing. You know, maybe it's 10 long, maybe it's 100 long. I don't know. So this little thing here, it's not. Notice it's not a method on the array object. If it were a method, I would have to do a method call here. It's something a little more mysterious that we'll sort of learn about as we start building our own classes, but we don't really know what it is yet. So it's just a little bit, just have to get used to it. Arrays have a dot length that evaluates to the length of that array. And then I want to increment the index. Okay, and I'm only going to do one line, so I'm not going to do some curly brace statement body here. And I want to take array at index, and I want to set it to a value. And if I want to go 0, 1, 2, 3, 4, 5, fortunately, my index is that value, right? So the first time in, at the 0th index, I want to put in a 0. And at the first index, I want to put a 1. So they match up nicely, right? So I can use index here to kind of do this counting for me. Something more complicated, I might have to make an int counter and then make array index equals counter, and then counter equals counter times 3 or something like that, you know, if I want to do something fancier. But I don't have to do it fancier here. All right. Now notice I'm not returning a new array of the same size that's filled with this. I'm changing this values array. And again, the reason this works is that in Java, when I pass in values as an argument here, this parameter references the same object. So values is, filled with zeros. Not with, I think I said 5 of them. So values references this object. When we enter the init array method, then R also references that exact same object. So if I change the array that R references, it's also changing the same array that values references. And so I'm really changing both at the same time. When I say both at the same time, there's only one object. So it's not really two different things. Okay, so if I were to run this, starts off 0, 0, 0, 0, and changes to 0, 1, 2, 3, 4. So don't get confused that this is somehow a distinct object. Again, it is referencing values because I pass that values reference to this parameter here. They share the same object. And changes to this are really changing values at the same time. Right? It's really important that you get that idea down kind of solidly. Now, if I wanted to instead use values as some sort of template and make a new array, 0, 1, 2, 3, 4, of the same size, what could I do instead in this method here? So again, I don't want to change values. I want to instead make a new array, the same length, but filled with the values that count up instead of all zeros. What would I have to do? So if I change index to 1 here, we're still going to be working on the same array. Array here is the same as values, and so it would still be changing values inside this loop here. So instead if I wanted a distinct array, what can I do?
Create a new array.
I need a new array somewhere, right? Where am I going to make that new array? I got to make it in here.
What do you call a method?
Well, I could have passed in some sort of copy here or something, but instead I'm going to make an int array, new array, that is the size I want, new int of the same length. And here I would change new array, but I'm still trapped inside this method. When I leave scope here, new array goes away. So how am I going to get this value back to main? What do I need to do? I need to return it, yes. So I need to return new array and make the return type be that of an int array. And here, say an int array changed equals whatever returns from here. Okay, now the weird thing is, let's go through the objects in this a little bit more detail. All right, so in main, I have values. And I'm making that reference something with 5 elements in it, an empty int array. I call init array with values, so the reference that's stored in values gets passed to R. I gotta change that name, I can't stand saying that. R. So we're referencing the same object in the heap, in the memory here. Then I'm making a new array. And that references its own object that was default initialized to zeros. It's a separate object. Then I go through and I change what's stored in each one of these. When I'm done, I return this reference, which means that this call up here evaluates to this reference. And we assign this reference to something new called changed. So this is another array reference. It gets the value of this reference. And so it also references this object that was made in the other method. But we basically managed to pass that array out of the method by copying these references here. Okay, so we create new array. That object is hanging out where all methods can refer to it if they know where it is. And then this method call, because it has a return value, evaluates to whatever is returned, and we're returning new array. But again, we don't really return the array, we return the reference to the array. And we store that reference in changed, and now we can access this same array object through the changed reference here. And so I would print out here changed, and when I do that, that changed one has come back. If I print out, let's print out some actual references. So I'm going to print out changed reference, and I'm going to look at what changed is, and I'm going to print out the values reference. And I'm going to print out new array down here once I'm done. Now, I know many of you are not that interested in all these printfs, but they tell you a lot about what's really going on in the system. And you'd be wise to experiment a little bit on your own with this kind of stuff. So let's run this. And all right, values reference is at this weird location, but again, objects have their own unique address, and so if these numbers are the same, it's the same object, and if they're different objects. That's really all you have to know about. So values array is stored at this location. We create this new array that's stored at this location. This reference, again, is what's passed out by the return value and gets assigned to changed. So changed holds this reference, which is referencing the same object, right? That is the key. So I can, whatever changes happen to new array have also happened to changed at this point. And if I changed, then it's the same thing. All right, questions. You need to get this rock solid. So if you're confused about it, you've got to somehow go through these slides, go through the notes, talk to us. I would write code, add little print statements in. And again, there's a difference between printing out the reference, the variable itself, and printing out the internal structure of the array, the object that it references, okay? And using both of those tells you something about what's going on here, because you can't be sure if you just see an array 0, 1, 2, 3, 4 is the same as another array 0, 1, 2, 3, 4, if those are different objects, or if they're the same objects referenced through a different variable name. And you need to figure out which one is happening to be sort of solid in the model here, what's going on. Okay, so questions first of all, before I turn it on. I know this is the kind of thing that if you're confused about it, it's hard to know what question to ask, but anything? Venture something here? Okay.
So everything that you did with values are new array and changed, was that just to prove the point of references? Because I got lost in like all the different things we did.
So
arrays and why we did that.
Originally, I was passing in values and changing the object values through a different reference name here to show that it changed inside the method, and that change is escaped from the method, right? That's when that was a void here. When I'm returning something, I'm typically wanting to create a new array. Maybe I don't want to mess up values. In this case, values only had purpose in providing the length that I'm trying to create there. It didn't really have any other, it could have been filled with any numbers I wanted, right? But we're not messing with values at this point because now we're creating a new one that's the same length and doing stuff to that one and returning it. And you will see methods that have both approaches. Some will change the array itself if it's passed in, and some will try to create a new array with some new values in it. And you have to, again, be a little cautious about what's going on. And typically, the key here is if you're returning an array, it means you're really trying to create something new. And if this were void, then like what purpose does a function have that's void? It's not computing something. Instead, it's doing some actions that change the array passed in. So if that's void, typically it's going to affect the array passed in. And if it's this, it's going to be changing it's going to be creating a new array and filling with some values. Now, I could have been sort of evil here, and if I had done like return values here, then that int array thing isn't telling you the right kind of thing. But anyway, you'll start to see these patterns, but it's important to pick up on those details. Otherwise, the model in your head of what you think is going on is wrong, and so when things don't work out right, it takes a while for you to go backtrack, realize that your thinking was a little messed up about what that method did, and try to fix your thinking, and then you can kind of fix the program because you can use these correctly. And again, these numbers are all horrible looking, weird things, but key is, are they the same objects? Are they different objects? That's really the only thing that we care about at this point. We don't care where they seem to be located in memory. That doesn't mean anything to us. Okay, anything else on that part? All right, somehow in my mind that was going to take like 3 minutes, but well worth the time talking about it. Okay, so we talked about different kinds of loops. An enumeration loop does something to each element of the collection we're working on. An accumulation loop does something, accumulates some answers, it looks at all the values in the array. An optimization loop helps you find the best or worst of something. And then I forgot to write here, just searching loops. So let's sort of see how these play out in the context of arrays. So first of all, again, we started using this length thing without talking about it. You just learn array name dot length tells you how long that array is. Okay. That's where we were. All right, let's say we want to add one to each element of an array. So we need some kind of an array. We're going to pass that into a method. We want to modify the actual array rather than making a new array, probably in this case. We're saying add one to the array. And so we need to march over all the elements of the array, and every time we see a value, we add something to it. All right, so it's pretty simple. We have, in this case, vals is a reference to this array. We want to track what index we're at with some sort of integer value. And again, last time in my code, I used the loop for that. For index equals 0 goes to the length. And it all works out kind of nicely. You could do it with a while loop if you want to, if you have a variable tracking that index. But in general, we usually use for loops for marching over arrays because we know how long they are. All right. So we go, if the index is, when the index is 0, we grab the value out of it and add 1 to it. When the index is 1, we grab the value out. Notice we're going from 3 to 4 here. Change the value stored in there and go to the end. When we reach the end, we stop. So let's just write up code for that quickly. All right, so public, static. In this case, again, I'm changing the array, so I'm not going to return a value. It's just that the changes are going to persist from the method. And we're going to call this one add 1 to each element. And it works on an int array. I'm going to stick with that dumb name, R. All right. This has the same pattern and everything else as all sort of are working with arrays and strings and scanners. So we're going to have some loop to go over each element. Int index equals 0. Index is less than array length. Now, some of you are going to be wanting to know, like, you know, do I go less than or equal? What did I just do there? Do I go less than or equal? Do I go less than? Do I do not equal? You know, what's the right answer here? And again, if I have an array of 5 elements, its indices are 0, 1, 2, 3, and 4. What is the length of this array here? 5. So I want to go while these values are less than the length. And again, that's because we're starting counting at 0, and 0 to 4 is actually 5 things. So we've covered all of them, but we do not want to hit index 5, so we stop when we are less than the length. All right? And then I increment by 1. If I want to add 1 to each element, all I have to do is say where we're at. And I get the old value that's in there and add 1 to it. Okay, so this says at the current location I'm at, what value is stored in it? 0. Add 1 to that. It's a 1. Store it back in that location. So that turns into a 1.
Yeah. So could we still use arguments like, excuse me, r index plus plus, or do we need to write it out?
Yeah. So I was just sort of, I like sometimes to spell out so the expression is a little clearer, but
okay.
You can do plus equals 1, and that says add 1 to this thing, or we could do plus plus.
Just want to make sure we still.
If you're sticking with adding 1, right? So all those work in this context. Yeah.
What situations would we want to use since void would change the array anyways? What situations would you want to use void, and what situations would you actually want to return an array?
So a lot of times with arrays, we want to just mess with our array. Here's some data. Let's mess with it. There's no reason to make a copy of it, right? I mean, you could do that, but at some point that's not as efficient. So it's not as efficient to allocate another chunk of memory so to copy values over one at a time and do something to it. It's more efficient to leave that object hanging out where it is and just modify it in place. Now, if for some reason I needed to retain those values for some reason and then make changes to it and have a second copy, then you got to make a copy, right? But it all depends on whether you need the old values or not and whether you want to be more efficient, I guess. So pretty commonly you'll see these be just changing the array that's passed in rather than making a new one. So let's try this one out. So if I add 1 to each element of values, and then print out values. Let's identify which one this is. And I run it. So value started off being default initialized to 0. I added 1 to each element, and it becomes all 1s. Very exciting, right? So, but notice values changed, and it did what we wanted. All right. Let's say we wanted to add up all the values in here instead. So I'm going to copy this code and call this sum up some elements. Sum in the sense of adding up, not of like some of them. And in this case, what kind of value is going to come out of here, do you think? Am I changing the array when I add up the values? I'm just sort of using the array in that case, right? So I'm going to return some value, the sum. And because I'm adding up integers here, I can return an int, and we're safe. If there's something else, I might have to return doubles or something like that. And I don't want to change my array here. I just want to use it. So we've seen this pattern before of adding things up, like adding up numbers in a string. This is an accumulation loop. What's like the first thing you need to do in an accumulation loop? Yeah, I need to create your summing variable. I need something to accumulate my answer in. And I need to initialize it to some starting value, right? So I'm going to say my sum is 0. And again, sometimes think of this as sum so far, right? It's not immediately the right answer. Like sum is 0 is not correct. But at this point in our algorithm, this point in our calculation, what we know about the sum is that it's 0. We haven't added any elements to it yet. So I mean, if I were writing code for myself, I would just say sum. But in this context, I sometimes like to write a little more description saying this is accumulating the sum as we go through our loop. So we're going to look at each element at a time. So here, look at the array at index. What do I want to do with this value?
Sum equals that value.
So I have a sum equals 0, and I'm going to look through and I'm going to say I have an element 0, an element 1, an element 2, an element 3, an element 4. What do I want to do with those values? Add them to sum, yeah. So sum plus equals the new element that we're looking at. And at the end of this, I can just return sum. Sum so far in both these places. Okay, so the idea is we still loop over all the elements of the array, and at each one we grab it and add it to this accumulation variable, sum so far, and keep adding in new parts until we get through the loop. When we've looked at all the elements, we've added them all up, and we can return that answer back to our calling function. So up here, I'm going to make a variable in sum. I have to capture that value coming back from my call. And I already kind of forgot what this is. Sum elements. And it's kind of boring to sum up all ones, so let's sum up changed. And then we can print out the sum is space sum. And if I run this, the sum is 10. And if you add up These numbers here, 3 plus 4 is 7, that's another 3, that's 10. Add 0, 10, so do the right answer. Yay, right? So there's a lot of different styles of these things, but notice they're all, I mean, what I really want to get across is that there's some real basics that you just have to handle, and then you can kind of do all the variations, right? So enumeration loop, you just loop over all of them and do something to it. Print it out, add 1, whatever you want to do. Notice also we can do something in our enumeration loops. In scanners, all we could ever do was grab it and print it because we weren't allowed to change the scanner itself, so we couldn't really do anything very interesting with enumeration loops. But now we have arrays that can actually do little tiny computations on the values and change them. You know, so it's an enumeration loop. Enumerates each item and does something to it. This still has a loop, but we have this little accumulation thing. So again, these patterns, and you got to get used to them and sort of master them, be facile with them. Okay, so these things should start to get familiar. You should be able to write these things, kind of just like turn them out as fast as you can, kind of get asked the question at some point. All right. Better march along here. Add up the values. Let's look at an optimization loop within arrays. So again, in an optimization loop, we're searching for something like the smallest or biggest value in some collection. We did that with scanners. Now we're going to do it with arrays. And again, we're going to maybe assume that there is at least one value in the array, just to make things a little easier for us. And we're going to grab that first element out of the array as our current known best answer. And then we're going to search the rest of the array for something better. And if we find something better, we keep track of that new value. So again, we might have an array referencing some array object. We start at 0. Smallest so far, we initialized with that first value that we found, 6. We know that's going to be at least a reasonable choice, because maybe all these numbers are going to be bigger than that. Maybe they're going to be smaller than it, but it's not like a wrong answer. So we want to then start at index 1, and we ask, is 1 smaller than 6? And it is, so we're going to change smallest so far to be 1. We go to the next value, the next index, and we check to see if 5 is less than 1. It's not, so we keep the 1 in there. And when we run out of elements in the array, we return what that smallest value that we found is. Okay? So it's the same kind of thing we did before. It's the same pattern. Instead of doing a while loop with while has next integer or something like that, we're doing a for loop and going from the 0 index to the last index, and each time through comparing the value of that location with what is their best one so far. So the only difference here is that we're using an array instead of a scanner. The logic of it remains the same. Somehow, okay, searching for a value. Same kind of deal. You want to find out if some value exists in the array. So you're going to pass in an array, and you're going to pass in what we call the key. And if the key exists in the array, then we say true, otherwise we say false. We loop over all the elements in the array, and if we find a value equal to the key, then we know it exists, so we can return true right away. We don't have to keep searching anymore. And if we haven't returned true at some point in this loop, then we return false, meaning we haven't found that item in the array. All right, so that's a basic search. Other options are I could return an int and return the index here, saying where I found it in the array. And sometimes that has use because you want to do something to that small thing that you found somewhere. So sometimes giving back the index is just as valuable, or even more valuable than saying it exists or not, right? The index tells you where in the array this thing was found. And so that's a nice thing to know. There are Java things that will help you do this, but it's nice to know how to do this yourself as well for various reasons. Okay, let's And there's code you can look at up posted. Let's talk about the assignment I'm going to put out today. So there's going to be some sort of stuff the same as before, little methods that make you practice things, and that's good. You should do those first because they will make you more comfortable with arrays and loops on arrays. But we're going to have our first sort of real project that does something here. All right, so we're going to write a program to analyze movie reviews. So this kind of thing is a very hot topic these days. People are very interested in the sort of analysis of like Twitter tweets and things like that. So our goal is to work with what's called unstructured data, and that's sort of a hot topic right now. So older computer programs usually try to deal with structured data. Structured data is organized very nicely. Structured data, there's some sort of table here. You know, under name, it's always a name. UID, phone number, office. It's very easy to identify what's what. Unstructured data is more like what you see, you know, text. Yo, my boys, that movie was lit. Emoji, right? Now, it seems like no one should care about that particular tweet because it's just sort of noise, right? But if there's a million people saying this to their friends, if you're a movie company, you're very interested that people are saying that about your movie. Now, you don't really want to have to hire some poor saps to read all these tweets and say, like, that person liked the movie, this person didn't like the movie, or something like that, right? So instead, we want a computer program that somehow is able to look at that text and pull some value out of it. Some sort of number saying, is this a positive sentiment about the movie, or is this a negative sentiment about it? And again, people are not writing tweets saying, movie, colon, you know, whatever movie they saw, my rating, colon, you know, this. They're not providing structured data. So people are forced instead to look at this huge amount of unstructured data and try to get value out of it. And companies are very, very interested in this. And of course, governments are also very interested in this kind of stuff. So this is kind of scary technology in a way, right? You're just saying casual things about things, and people are mining this data for how the populace is thinking about movies or revolution or the economy or whatever, and they are making policy decisions based on this kind of stuff. So I have a file, so we're using some files in this, of short movie reviews. I can't remember where I took this from some other person that collected it. Maybe it was like Rotten Tomatoes, one-line reviews or something like that. And what do you notice about these reviews, first of all? So if, you know, this is sort of unstructured, but there's some patterns to it. So what's something that you see about this? Yeah?
There seems to be like a score rating at the very beginning of every, so like a score value.
Yeah, so we're kind of cheating here. This is not fully unstructured, right? But movie reviews also have some structure typically. So the first number is some sort of rating that goes from 0 to 4. There's a limit to it. And we can count on the fact that there's a number to start this thing off. What else do you notice about this? Yeah?
They either have positive words or negative words.
Well, there's a bunch of words, and somehow we got to decide whether they're positive or negative, right? When we read it, we understand, like, well, I'll skip that one. Highly watchable. That's a positive sentiment. We understand what that means, right? The computer, of course, does not have any semantic knowledge of these, really. So we can't read it and say, oh, this means that they like this movie. Crisp storytelling stuff. So somehow, what else should you just notice about the text itself?
They always end in a period.
Okay, so the end of the period's actually a little weird. What do you notice about the period?
Separated.
There's a space, right? Someone went through this and actually did a little, what's called data wrangling, to try to make it easier to process. Because the problem is, if we had expecting period, that's a token. That period is part of the token. And so we would start having, we'd be like contaminated by the punctuation here. So someone went to the effort here of kind of separating all the punctuation. Notice the comma has space around it on either side. That's not proper English, but they added spaces so that these things get pulled off into their own tokens. So this comma doesn't contaminate watchable. Otherwise, somewhere we know there's a word watchable, and then there's a weird word watchable comma, and it would be considered different by the computer, right? It doesn't know the difference between it. It just knows what the tokens are in here. There's also something funny going on here exactly. I don't know what it is, you know, but Actually, it's trying to make a backslash for us, or slash. Typically, when you're working with this kind of data, a lot of the effort is in what's called data wrangling, where you're kind of trying to massage, clean it up in some form where the computer has a chance of kind of dealing with it. And that's a hard task all of its own. But this file I have is already pretty clean. So the project goal is we're given a bunch of these movie reviews, like, I don't know how many, like thousands of them, and the rating. And so there's a rating and a bunch of words. We don't even know what movie they're about. We don't care about that. We just care about the words and the rating they had. So we're going to go through each word and rate it as being sort of positive or negative by the kind of review that it's in. So if it's in a review that's a 4-star review, we say this word is associated with positive reviews. If it's a word that's in a negative review, it gets a negative value. Now, if it's in both, what do we do? Because, you know, the is going to be in positive reviews and negative reviews. So what do? We average it, right? So somehow we're going to accumulate some sort of total score and then average it to decide whether or not this is positive or negative. And then we're going to use these word ratings to rate new reviews that maybe the person didn't give a formal number to. So if we somehow decide that there's a tweet or something that's related to a movie, we're going to scan all those words and figure out whether the sum of all those word scores makes it seem like a positive review or negative review. So let's briefly look at how that might work. So we're going to break down text into words and scores. We're going to take a review. So one line basically at a time. We're going to put each word into a big array of words. Okay? So if I was starting off from the beginning here, would go in that first location, mix would go in the next location, that in the next location, draws, you, and then we have this mysterious punctuation word that we don't care that much about, but we don't care enough to kind of kill it off at this point, to clean it. We could clean it up if we wanted to. Okay? Now we know what the score is for this review, and we're going to make another array that scores each of those words that we put in there. Now this is a new concept for arrays. And in fact, in general, once we get into object-oriented programming or in Java, we won't be doing these sort of complicated things, but for now, this is what we have to do. We have two arrays, each the same length, and they are connected to each other, not by formal Java constructs, but by our own logic. So we're saying that a score at some index matches up with the word at that index, okay? So if I want to find out what the score is for draws, I'd have to find its index, 3, go over to this other array called scores, and pull the value out of it. So there's these multiple things happening at the same time in parallel here. And so in your mind also, you have to keep track of, like, these are the same sort of, they're connected to each other. Then we're also going to say how many times this word has appeared so far in all the reviews. So since we're just starting off, they all appear once, right? We found them and they appear once. All right, so then we go on to another review. It has a different score. We take the first word in it. If is not part of our existing set of words, so we add it to the end. Okay? And we go put its score there and its count. U did already exist. So we're going to add this score together to the old score in there and accumulate an overall score, and then add one to the count. And notice if we wanted to average that, we would take this score and divide it by the count to get 3.5 as sort of the average score for that thing. But we need both pieces, we need to track both pieces of information here. So there's 3 arrays. There's the words, the scores, and the count. And they're all important here to get to our final goal of associating a word with some sort of average sentiment. Yeah.
So I'm assuming that we have to use a sequential loop in order to see if the word hasn't come up already?
So I'm going to have you write some methods that decide whether or not a word already exists in the list, and so on. Okay, so you can find your average score by taking the scores at the location and the count at that location. Now, I keep saying we add to the end. Arrays are fixed in size, right? So we have a problem here. We can't just say, make the array bigger. Eventually, we will be able to say that. Instead, we're going to use a variable that tracks how far down the list we've used up already. So if we have all these words here, then we're going to say that there are 8 items that are used, And index 8 is the next location where we can start adding more words. So we're going to sort of have this, we're going to just start off by cheating and make this sort of giant list of, I think, 14,000 something words. Because that's how many words we find in the reviews. And at the beginning, we're going to say we haven't used any of them. And then as we add it, we have a variable like used or number of elements used or something. And it tells us where we can add in the next element. And then we add 1 to it to get to the next location. So we're now adding a new thing to the array, which is saying how many spots in the array are we actually using up. Okay? And we're going to use a variable to track that. This variable is going to be the same for our words array, our scores array, and our counts array because they're all getting added to at the same rate. We don't only add 2 to the count when there's only one word being added in. Okay? So then we want to estimate the movie rating. So we're going to use an existing rating out of the file because we know all the words exist in our ranking then. We're going to go through each word of the review, count up the score for each word, and divide by the number of words to get an average, and compare that to the actual review. And I'll tell you whether or not this is working kind of well. So if we have new review text, I love the thrilling emoji, wait, did I spell that right? Movie, score each word, I, sort of neutral, 2, loved, 3.6, the, pretty neutral, thrilling, tends to be good, emoji seems to be 0. Movie, 2, neutral. Total score, 12.8. There are 6 words, 1, 2, 3, 4, 5, 6. So to get your rating for that review, you would take the average of all those words, and the total score divided by the number of words, and get a rating of 2.1. Now in this case, it wasn't a very good estimate because someone saying, I love the thrilling movie should be a good review, right? But the fact that emoji was in there tended to kind of dampen down the computer's enthusiasm for this review, and it gave it a kind of a lower score. So this sounds sort of complicated, but really you're just going over loops, adding things up. And I'm going to break it into pieces for you so you can make progress without getting overwhelmed by the complexity of it. So look for it, think about the goal, and see how it goes. Hey, I got it.